So now let's do the fixed point method. So fixed point method is another method of finding approximate root of nonlinear equations. And what is fixed point? A fixed point, also known as invariant point of a function, it is an element of the function's domain that is mapped to itself by the function. So basically, what is a fixed point? X equal to f of x. If this occurs, then this x is known as the fixed point of function fx. Okay, so if for any x value, okay, so if for any x value the functional value at that point is same as that of the x value, and then it is known as what? It is known as fixed point of the function. Okay, so that is the thing. For example, I would like to draw something here. So this is my curve of y equal to x square, let's say, and you can see that at some point here the value of x and value of y would be equal, right? So this value of x, where its functional value, that is y, or we can say f of x, these are equal. That point is known as that x point is known as what? Fixed point. Okay, so that is the thing. So let's move. So fixed point, that is we denote it as f of alpha equal to alpha, and you can see that whichever points has the functional value same as that of the point, that is known as the basically the fixed point. So graphical representation. So let's see the graphical representation of fixed point. So if we have this kind of function like fx is equal to x square minus 2, then x is equal to fx gives the fixed point. Okay, so wherever there is x equal to fx, there is fixed point, that x is the fixed point, right? So we can say that fixed point is the point of intersection of y equal to x and y equal to fx. So this is our y equal to fx, right? Y equal to x square minus 2, and whichever point on this curve has the same value of x and y, right? That is x and f of x. If both are equal, then the line y equal to x should pass through that curve, and they both the both of the curve will intersect at the point which is the fixed point of the function fx, right? So we can see this. You can see that this is our y equal to x square minus 2, and this is y equal to x. So at this point, y equal to x function will intersect the x square minus 2 function, right? So that means that this point of intersection is the this point of intersection, that is x is equal to 2, is the fixed point of this function, that is x square minus 2. So that is the thing. And then how root finding problem is associated with fixed point. So how root finding problem is associated with fixed point. So the ultimate target of our ultimate target is to find the root of a nonlinear equation. But how this fixed point is helping us to find the root of nonlinear equation, that we will see now. Okay, so find the root of fx is equal to 0. So we have one question that is asking for the root of the fx equal to 0 function. Then we can write fx is equal to 0 in an equivalent form, that is x is equal to g of x. So we will represent that fx is equal to 0 in the form of x is equal to g of x. Okay, x is equal to g of x. So this x will be the no, not this x, like we got g of x, right? So we represented f of x into the form of x is equal to g of x. So this g of x is a function. So if we find the fixed point of this g of x, that fixed point will be what? That fixed point will be the root of the f of x. So that is the main concept. Okay, so first of all, what do? First of all, we convert the f of x equal to 0 function into x is equal to g of x function, right? And then we then we find the fixed point for the g of x function. So we find the fixed point for the g of x function. So the fixed point of the g of x function would be the root of the f of x function. So that is the concept. So we will see this in the graph as well. So let me just read this little bit. We can write f of x is equal to 0 in an equivalent form, x is equal to g of x, where x is the fixed point of g of x. This fixed point is the root of f of x is equal to 0. So that is the thing. Okay, so then f of x is equal to sine x equal to 0. Find the root of the equation. We can form g of x by adding x on both sides. So that means for this f of x equal to 0, that is sine x equal to 0, we have this fx is equal to sine x, right? So we have that fx equation, that is sine x. So we need to convert it into the form of x equal to gx. That means we can convert it by adding both sides x, right? So we have sine x is equal to 0. If we add both side x, then we will get x equal to sine x plus x, right? So that means that sine x plus x is the g of x. So we got g of x. Now I would like to show you in Desmos. Just a second. So so this is the function. So y is equal to sine x. This is the y equal to sine x graph. Okay, and this is the this graph, this blue graph is the function, that is curve of sine x plus x, that is g of x. So this first one is our f of x, second one is our g of x, and third is our y equal to x. So we are going to find the fixed point of g of x, right? So that is our ultimate motive. So right, so now what are we going to do is, let's see that we just studied that the intersection point of the function y equal to x and the g of x function. So that intersecting point is the fixed point of g of x, right? So that is the thing we are going to see here. You can see that this is g of x, and this blue is g of x, and this green is y equal to x. So these intersecting points, we can see this one, so pi gamma pi, 2 pi gamma 2 pi. So these are the intersecting points of y equal to x and g of x. That means these are the fixed points of g of x, right? So these are the fixed points of g of x. So we can see just here that pi, that is if we just see the x value here, we can see pi and 2 pi, right? And x and y are same here, obviously, that is why it is the fixed point. So we can see that x is equal to pi and x is equal to 2 pi are the fixed points. Likewise, we can get other points as well. You can see here as well, 3 pi comma 3 pi. So this 3 pi is also the fixed point of g of x. So in this way there are many fixed points because there are many roots of f of x, right? So that is the thing we need to understand here. So you can see there are many intersecting points in this g of x and y equal to x, right? So all the intersecting points are the fixed point of g of x, and those fixed points are equal to the root of this f of x. You can see that thing just here, because pi, 2 pi, 3 pi, these are the roots of sine of x. So sine of x was our f of x function, right? So this is f of x, this was g of x, and this is y equal to x. So the intersection of these to these two will give our fixed point, and then that fixed point would be the root of this f of x. That is the thing. So now let's move on to the methodology. So how do we solve the questions? So we are given one function, that is f of x, and we will represent it into x is equal to g of x. Then we will find the fixed point of g of x, and then after finding fixed point, that fixed point is the root of f of x. So the main problem arises in determining the g of x, right? So there are infinite many possible ways to determining, like representing the f of x equal to 0 into the form of x is equal to g of x. That means there are infinitely g of x representation for f of x equal to 0, right? So we can form many g of x. So which g of x will converge and which is the accurate g of x, so which will give us the fixed point value, so that we can find the root. So that is to be checked. Okay, that is to be checked. And not all g of x will give the not all the g of x converges, and not all the g of x has the fixed point. So we need to check the g of x. We need to choose the g of x, whichever g of x gives, whichever g of x converges, that will give us the fixed point value. Okay, so how do we know that which g of x converges? So converges means that difference between the values decreases. Okay, the difference, if the difference between the functional value decreases as the value of x increases, then we can say it as the converging function. Okay, so methodology is the so this is the formula actually, that is xn plus 1 is equal to g of xn. So we use this formula, and and whenever the difference between the g of xn and g of, I think not g, it is xn plus 1 minus xn. So whenever this difference is less than the tolerance value, then we stop the calculation. Then the root of the equation. So here is a question, and you can see that we can make many g of x. So this is g1 of x, g2 of x, right? And then we can also make many g of x values. You can see many g of f function. So we need to check. Here is a sample of checking. You can see an example that we are checking which of the g of x are converging. So some of the g of x goes on increasing and increasing, right? So that kind of g of x should not be taken. With what kind of g of x should be taken? So we can directly check into the calculator, right? By just if we are given the interval to find the root, then we can just directly put the interval and try to check that which g of x converges, right? That means which g of x are coming close. That is the g of x will come close to close. Okay, close to close values, right? So it will like approximate the value. So if the difference is going on increasing like when we put x equal to 1, then it is like 16 value, and then when we put x equal to 2, then it is like 100 and something. So this kind of gap, that is a huge gap, right? So whenever we increase this gap, that gap goes on increasing. So this kind of g of x should not be taken. Okay, so what kind of g of x should be taken? When we put x equal to 1, then we get 1.61. When we put x equal to 2, then we get 1.7. And then when we just increase the values, then it begin to just increase very slightly. Okay, so that kind of property is known as the converging property. So that kind of function are known as converging functions. So the convergence can occur in a fixed interval only. So in the question, interval may be given as well, and sometimes we need to find interval ourselves as well. So in that case we can use IVT, that is intermediate value theorem, to find the interval where the root lies. Then we can use that interval, right? So and one more thing is so one more thing is whenever we just tested for the g of x, and we just found out in calculator that this g of x converges, right? So then we need to prove it, this g of x really has a fixed point. So that kind of thing we need to prove, that thing we need to show that thing in the paper while writing in examination. So that is the thing. So how to do it? So how can we prove that the g of x really does contain the fixed point, and it converges? So this kind of thing can be proved by three conditions. So we have three conditions. First condition is that the g of x should be continuous in the interval a comma b. So we will be given the interval in the question, so we can directly use that interval a comma b, or if it is not given, then we can find the interval by using the intermediate value theorem. And then another condition is g of x belongs to that interval a comma b for all x belongs to a comma b. So whatever is the range of the, let's say, whatever is the range of the interval, let's say whatever is the interval of the x, so g of x, the value of g of x should not exceed that value, that range. Okay, so that range should not be exceeded whenever we put the values of x of that range. For example, we have interval 1 comma 2, then whenever we put any value between 1 comma 2, okay, between 1 and 2, then the g of x should be also be under the range of 1 to 2. Okay, so that should be the range of the g of x as well. So that is the second condition. And the third condition we have is the derivative of g of x. The first derivative of g of x would have the maximum value less than 1. Okay, so this is the absolute value. Actually, the absolute value of first derivative of g of x should be less than 1. Okay, so if that occurs, then if we can directly check this one first. Okay, so if this occurs, then we can directly say that if this occurs, then we can directly say that it converges. Okay, g of x converges, and it is actually to prove that there is a unique fixed point in that interval. It actually proves the unique fixed point in the interval. That thing is only proven when the above conditions are already proved. So if above conditions are already proven, then we can just prove by using this third condition, that there is only one unique fixed point in that interval. So we have three conditions. That is, first one is the continuous on the interval, second one is the g of x belongs to a comma b for all x belongs to a comma b, and then the absolute value of g dash of x should be less than 1. So that is the thing. Okay, so these are the three conditions. So now we can see, so that g of x equal to x square minus 3 has a unique point on minus 1 comma 1. So we can just prove it by the continuous is proved itself because it is polynomial, and then that g of x belongs to minus 1 to 1, so that is to be proved. So for that we can find the maximum value and minimum value, and we can just find the first derivative, and we will find that first derivative is less than 0. That means it is decreasing function. So that means the lower value of x will have the highest that is the highest value, the functional value, right? So that is in the interval of 0 to 1, and in the interval of -1 to 0 it is increasing, and -1 has the lowest value and 0 has the highest value. So if the highest and lowest value are in the range of this interval, that is -1 to 1, so that means all g of x belongs to the -1 to 1 for all x belongs to -1 to 1. So we can say that thing. And then the third condition is g dash of x should be less than 1, that absolute value. So for that we can just replace that x with such value of x that is given in the interval, so that the gf value becomes the maximum, that is g dash maximum of x, we can represent it like that. So g dash maximum of x, the absolute value of that. So if it is less than 1, then we can directly say that it has the unique fixed point. All the condition will be satisfied in that case. So here is our another question. So it is also the finding the fixed point of the functions. So if we can find the fixed point of the function, then we can easily find the root. So but the headache is the g of x function. So how to make g of x function? So we need to try making different g of x function, and we can directly check in the calculator by using the values that is given in the interval of the question. So we can check that thing, and then if we check that thing, whichever converges, then we can directly use that, and first of all prove that it converges and the fixed point exists, and then we can directly find the fixed point and root as well. So that is it. And then this question is something different, that is 3 to the power minus x. So it is continuous, right? So it is continuous. It is continuous, and it is decreasing in 0, 1 because it is exponential to the negative power. And then we can directly prove this thing easily, but the third condition isn't satisfied in this case, because 3 to the power minus x has the derivative of its derivative will be minus 3 to the power minus x ln of 3. So if we replace the x with the in such a way that the g dash of x becomes the maximum, that absolute value maximum, then we will get a value which is more than 1, okay, which is greater than 1. So in this case we can see that the third condition has failed, but still graphically we see that there is a fixed point existing. So we conclude that even though there is a fixed point, the condition is not satisfied. So it concludes that the condition g dash of x, absolute value of g dash of x is less than 1, is only sufficient condition but not the necessary condition. Okay, so if this condition is satisfied, that means 100% it is it has the fixed point. Okay, so if this condition is not satisfied, then we cannot say that it doesn't have any fixed point. So that is not the necessary condition, but it is sufficient condition. If this is proved that this condition is satisfied, then we can directly say that the fixed point exists, and we can do the iteration. So here basically we use that formula, that is xn plus 1 equal to g of xn, and then we will find g of xn. First of all, we will let x not equal to any value in the interval, right? So whichever interval we are given, so we will use one value from them, and we will find g of xn, right? So g of xn, no, not the g of xn, we will find xn plus 1, that is equal to g of xn. So inside of g of xn. So first of all we will write g of x naught, that will give xn, sorry, x1, and then we will get x2 by using g of x1, right? So the previous value of x will be used to find the to find the new value of x. So that is the thing. So this one is finished. Now let's go to this one, that is fixed point, second one. This is the second one. So it contains basically some questions, I think. So let's go and see. So that g of x equal to 2 plus sin x has a unique fixed point in 2 comma 3. So the same question again. So we need to satisfy all the three conditions to say that it has the unique fixed point. But if the third condition is satisfied, we can say that it has a fixed point at least. Okay, at least one fixed point is there. But to say that there is only one fixed point, then we need to also show that first two conditions as well, that is continuous and g of x belongs to interval for all x belongs to interval. So that is I don't think there is any other thing that I need to say, because so yes, there is one thing that I need to say, that is g of 5. Okay, there is where is g of 5? Okay, you can see this thing. So whenever we are finding the g of x, that is the most headache that is the headache actually for this fixed point method. But to find the g of x, we can use the Newton's method. So we have Newton's method. This is like a shortcut to find the g of x. So we can directly use x equal to x minus fx divided by f dash of x, okay, to find the g of x. So x equal to x minus fx divided by f dash of x. Again, x equal to x minus fx divided by f dash of x. So this is the formula for Newton-Raphson method. That is xn plus 1 equal to xn minus f of x divided by f dash of x. So I think that is the formula. Xn, sorry, on the right side it is xn, and left side it is xn plus 1. But we write it here as x equal to x minus fx divided by f dash of x, and then the right side would be the g of x. So we can directly use this to find the root. Okay, so to find the fixed point. Okay, I think only the convergence has remained. So this convergence I will cover in a separate video for all of the methods, that is bisection method, maybe not sure about bisection, but fixed point and Newton-Raphson, these two will be covered in separate video. So I will make a video on that as well. So order of convergence, under the order of convergence, and that is important as well. So let's end this video here.